Welcome to our visual journey into the inner product. The inner product, also called the dot product, is one of the most important operations in linear algebra. It takes two vectors and produces a single number, also called a scalar. Let's see what this means visually. Let's build intuition by visualizing vectors. Here are two vectors in 2D space. Vector A in red points to coordinates 3, 2. Vector B in blue points to 2, 3. The inner product multiplies corresponding components and adds them. 3 times 2 plus 2 times 3 equals 12. The inner product works in any dimension. Let's try 3D vectors. Multiply each pair. 2 times 4 is 8. 1 times 0 is 0. 3 times 2 is 6. Sum them up. 8 plus 0 plus 6 equals 14. Notice how we multiply components in the same position and add them all together. Here's the beautiful geometric meaning. The inner product measures how much two vectors point in the same direction. But what does this number actually mean? Imagine the inner product as a measure of alignment. Think of a light shining from above. The red vector casts a shadow onto the blue vector. The inner product is directly related to the length of this yellow shadow. When the vectors point in the same direction, the shadow is long and the product is positive. Now, watch what happens as I rotate the red vector to be perfectly perpendicular. At 90 degrees there is no shadow. The inner product is exactly 0. This is called orthogonality. If we keep going, the vectors oppose each other. The product becomes negative. If we project vector B onto vector A, we get this component. The inner product is related to this projection length. In fact, the dot product equals the length of A times the length of B times cosine of the angle between them. The inner product has several important properties that make it useful in mathematics and applications. Property 1, it's commutative. Vector A dot B equals vector B dot A. Order doesn't matter. Property 2, it's distributive over addition. You can distribute the dot product across a sum of vectors. Property 3, scalar multiplication can be pulled out. If you scale a vector, you scale the result. Property 4, a vector dotted with itself gives its length squared. Always positive unless the vector is 0. Let's look at some special cases that reveal deeper insights about vectors. When the dot product equals 0, the vectors are perpendicular. We call them orthogonal vectors. When vectors point in the same direction, the dot product is maximized. It equals the product of their lengths. When vectors point in opposite directions, the dot product is negative. This tells us the angle is greater than 90 degrees. The inner product appears everywhere. Let's see some real-world applications. In coding and machine learning, we use the inner product to measure similarity. We use NumPy to compare data. If the product is high, the data points are similar. Let's recap what we've learned about the inner product. Thanks for watching. Keep practicing with different vectors.